High above us, invisible rivers flow across the sky. These rivers are not made of liquid water, but are composed of water vapor, which is a crucial component of our planet's weather system, originating through evaporation from oceans, lakes, and rivers, rising into the atmosphere. We call them sky rivers, or more formally, atmospheric rivers. These rivers can stretch for thousands of kilometers, transporting enormous amounts of moisture across the globe. Imagine a corridor of moisture in the sky, thousands of kilometers long and hundreds of kilometers wide, like conveyor belts moving water vapor from one place to another. Invisible to the naked eye, they carry more water than all the mightiest rivers on Earth. In fact, a single atmospheric river can transport more water than the Amazon River. But how? The atmosphere, a dynamic ocean of air, is in constant motion. This movement is driven by the sun's energy, which heats the Earth's surface unevenly, creating wind patterns. Water evaporates slowly, as invisible vapor into the sky. The vapors are then carried by winds, forming the basis of these atmospheric rivers. These water vapors travel vast distances, forming these aerial rivers that crisscross our planet. They play a significant role in the global water cycle. The sky rivers, though unseen, are not unfelt. They can bring heavy rainfall and storms, impacting weather patterns and climate in various regions. They play a crucial role in shaping weather patterns across the globe, bringing life-giving rain. Their influence on our environment is profound. Understanding these celestial waterways is vital to comprehending Earth's delicate climate balance. By studying them, scientists can better predict weather events and mitigate their impacts. The birthplaces of sky rivers are often tropical oceans where warm, moist air rises readily. As the warm air ascends, it cools and the water vapor condenses, forming clouds. This process is a crucial part of the water cycle, as it transforms invisible water vapor into visible cloud formations. Driven by powerful winds, often associated with weather systems like low-pressure zones, these moisture-laden clouds are channeled into narrow bands, forming atmospheric rivers. These rivers transport immense quantities of water vapor across vast distances. They play a vital role in the global water distribution, moving moisture from the oceans to the land. Similar to the rivers on land, they meander and shift, influenced by the Earth's rotation, temperature differences, and the terrain below. This dynamic movement can lead to varying precipitation events, active above the open ocean, accumulating their precious cargo of fresh water. This journey over the sea is crucial for maintaining the balance of the Earth's water cycle. The next, they may encounter a mountain range, forcing the moist air upwards. This interaction with the terrain can significantly impact local weather conditions. This ascent causes further cooling and ultimately rainfall. This process is essential for replenishing freshwater sources in mountainous regions. Water is the lifeblood of our planet, and sky rivers play a crucial role in its global distribution. They transport water from regions of surplus like the tropics to regions where water is scarcer, such as the western coasts of continents. Without these atmospheric arteries, many regions would experience significantly less rainfall. The western United States, for example, receives a substantial portion of its annual precipitation from just a handful of atmospheric river events each year. These sky rivers are not just about delivering water. They also play a crucial role in regulating Earth's temperature. The vast amounts of heat absorbed by water vapor during evaporation are released when the vapor condenses in the atmosphere, influencing global weather patterns. Imagine a gentle rain falling on parched land, bringing relief to the dry, cracked earth. Soil eagerly absorbs the moisture, and the plants begin to revive, the leaves unfurling to welcome the life-giving water. Or a torrential downpour drenching a city, where streets begin to flood, and the urban landscape struggles to cope with the sudden deluge. These events, though seemingly different, are both influenced by the same atmospheric rivers. These narrow corridors of concentrated moisture can transport vast amounts of rain across great distances. The intensity and distribution of rainfall are often dictated by the strength and path of these atmospheric rivers. They can bring beneficial rains or cause severe weather events depending on their behavior. When an atmospheric river encounters a landmass, particularly a mountain range, the moist air is forced upwards. This forced ascent causes the air to cool, leading to condensation and precipitation. The process is similar to wringing out a sponge, releasing the moisture it holds. This cooling effect results in the formation of clouds and eventually rain. The higher the mountains, the greater the uplift and the heavier the rainfall. The higher the mountains, the greater the uplift and the heavier the rainfall. This can lead to significant precipitation events, especially in regions with tall mountain ranges. However, the same mechanism can also unleash devastating floods. When the rain is too intense, beyond the land's ability to absorb it, it can lead to flash floods and other hazards. When a potent atmospheric river stalls over a region, the prolonged rainfall can lead to severe consequences. Or when multiple atmospheric rivers converge, their combined moisture can result in extreme weather conditions. The result can be catastrophic rainfall, leading to widespread flooding and landslides. These events highlight the dual nature, capable of both nourishing the land and causing destruction.
Check 1, check 2, check.
Human activities, particularly changes in land use, can have a significant impact on the behavior of sky rivers and their subsequent effects on rainfall patterns. Deforestation, urbanization, and agriculture all alter the Earth's surface, influencing how much moisture is absorbed or reflected back into the atmosphere. Forests, with their dense canopies, act like giant sponges, absorbing rainfall, slowing runoff, and releasing moisture back into the atmosphere. Deforestation disrupts this cycle, leading to increased runoff, soil erosion, and potentially more intense flooding events. Urban areas, with their concrete surfaces and lack of vegetation, create heat islands that can alter local wind patterns and affect the intensity and distribution of rainfall from atmospheric rivers. As our planet warms due to climate change, the delicate workings of atmospheric rivers are being disrupted. Warmer temperatures lead to increased evaporation, resulting in more moisture being held in the atmosphere. This can make atmospheric rivers even more potent, leading to more intense rainfall events. However, climate change is not just about warmer temperatures. It's also about changing wind patterns, shifting ocean currents, and altered jet stream behavior. These changes can influence the formation, path, and intensity of atmospheric rivers, leading to unpredictable rainfall patterns. Some regions may experience more frequent and severe droughts as atmospheric rivers are diverted or weakened. Others may face increased risks of catastrophic flooding as these sky rivers become more potent and unpredictable. Understanding the complex dynamics of sky rivers is crucial for predicting future weather patterns and mitigating the impacts of climate change. Scientists are using sophisticated computer models, satellite observations, and ground-based monitoring to study these atmospheric phenomena. Research is focusing on several key areas. How will climate change alter the frequency, intensity, and paths of atmospheric rivers? How will changes in land use, such as deforestation and urbanization, affect rainfall patterns associated with these sky rivers? By unraveling these mysteries, scientists hope to provide earlier warnings of extreme events like floods and droughts, and help communities adapt to the challenges of a changing climate. As our climate changes, we must learn to adapt to the altered behavior of sky rivers. This requires a multifaceted approach, encompassing improved forecasting, resilient infrastructure, and sustainable water management practices. Early warning systems are crucial for giving communities time to prepare for extreme rainfall events. Investing in resilient infrastructure, such as flood defenses, drought-resistant crops, and efficient water storage systems, is essential for mitigating the impacts of these events. Sustainable land management practices, such as reforestation and urban greening initiatives, can help regulate water cycles, reduce runoff, and mitigate the impacts. Invisible though they may be, sky rivers play a vital role in shaping our planet's climate and sustaining life on Earth. As our climate changes, these atmospheric rivers are changing too, posing both challenges and opportunities. By understanding the intricate workings of these celestial waterways, by unraveling their mysteries through scientific inquiry, and by adapting our behaviors to live in harmony with them, we can ensure a future where both humanity and nature can thrive. The fate of our rivers in the sky is inextricably linked to our own. It is up to us to ensure that these life-giving arteries continue to flow for generations to come.